So, welcome everybody to the Helsinki Data Science Meetup, and today we're hosting it with KONE, and we will have some very interesting talks by them. And first, a couple of rules of a code of conduct about this meeting. So there are more than 400 people have registered today, and by default, visitors are mute because there's so many. If you have any questions, please place them in the Q&A box. And after each presentation, we will have the time also for Q&A. So also please be active and post your questions there. LinkedIn and Twitter are open. I'll show quickly the hashtags in a minute. And same goes, if you have some issues, let the moderators know in the chat feed what's going on. And here's the hashtag, also Helsinki Data Science Meetup, that you can use needed. And here is today's agenda, as said, with KONE. First, we'll discuss with Maija Hovila, who is the head of analytics, about the new analytics team that KONE is building up. We'll hear some interesting insights there. After that, Olli will tell about the 24/7 connected services. Then we have something about the KONE's people flow services, and afterwards doing a poll and a couple of words about the next meetup. So a couple of words about before we let the KONE people speak about us. We're DAIN Studios, and we're hosting this data science meetup, but we also do other things. We are consultancy in data science, artificial intelligence, data in Finland and in Germany. We have some 30 plus experts, data strategists, scientists, and engineers, and work with a number of industries and companies in manufacturing, in media, in telcos, pharma, and so forth in 5 countries. So mainly in Finland and in Central Europe. And what is the Helsinki Data Science Meetup? So this is a series of events. Used to be a physical event. Now this is our 3rd virtual event. So it's that the concept is such that it's always interesting client companies that are do fascinating stuff in data science, and they tell about their real use cases, and we're in that sense always have this one company to be hosted. And at the end, I will also share some ideas about if you want to host a Helsinki Data Science Meetup going forward. And here are some of those tags that if you want to get involved with the meetup community, you can simplest probably is to send us an email to info@dainstudios.com. But there's also a very active LinkedIn group, Slack channel, and also a meetup. We have asked people a couple of times about their background. And I believe this might have been from last time when we were at Helen in November. So roughly 40% are data scientists, then some data engineers, business intelligence, business functions, and others. So this is really a community of data practitioners, very much. And actually at this point, I would like to stop sharing and like to introduce Maija. You're Maija still on mute. If you want to unmute yourself. So yes. So Maija, you are the head of analytics at KONE. You haven't been very long at the job yet, but maybe you would like to tell us a bit about what did you do before, about your background?
Yeah, so I've been at KONE about a year and a half. Time actually flies quite fast when you're having fun. So I moved back to Finland for this job, but so I was in the UK for almost 10 years. My background is firstly in consulting, so I did management consulting and focusing a lot on the kind of data stuff, and then actually in the UK, I was doing analytics consulting. So at the time, I was at the Capgemini Consulting, and there was a specific analytics practice helping companies kind of trying to use more than Excel and get a bit more advanced on utilizing analytics. And then from there, from consulting, I moved into industry, and then I was at the Unilever in the global team for about 5 years. So building the analytics team it was actually within marketing. So basically, we started from scratch and building up the team. Then by the time I left, it was about 250 people. So really kind of changing the way that marketing was looked at, and how do we understand the consumers and the customers, and what do they do, and then how do we help the kind of product development and all kinds of stuff. So really cool stuff. For example, Lipton matcha tea was launched based on the insights that we saw that was happening, and Magnum Vegan was actually one of the insights as well. People were asking a lot about whether Magnum is vegan friendly, and then that was one of the kind of ideas that came from the data that we were collecting and then analyzing, and lots of other stuff as well. So yeah, really interesting, building up the team and the capabilities for the global organization.
Yeah. So what about KONE? What is your current role there?
Yeah, so I'm heading analytics across KONE, so across the business lines and functions. So building up our analytics capabilities. So basically, first we've been thinking a lot about the operating model. So how do we organize ourselves for the whole company? So of course you'll hear later on today about some of the advanced areas where we are already quite far, but then there's a lot of areas in the company that are not so far. So how do we operate so that we kind of push our capabilities and our competencies forward, and we utilize data for the company as an asset and really get the best value out of it? So a lot of working with the kind of leadership team on the kind of strategic agenda, how do we bring data into the strategic agenda, and then thinking about, as I said, about the operating model. We've done some kind of maturity analysis across the different areas, kind of where are we in the different areas and what is the ambition, how do we then kind of build the plans for the various domains, and then of course also identifying the competencies, the skills that we have in the company already, and how do we build the profiles for people, and how do we then start training people in kind of pushing forward their careers, and then also kind of like citizen data scientist development, who are people who are maybe in the beginning of their career but very interested in kind of building more of their skills in the data area. So those are probably the main areas.
How would you compare? You said Unilever and now KONE. So what are the similarities and what are the differences between those companies?
I think as companies, we are quite actually surprisingly similar. So global companies are very driven by the local businesses, so where the business is actually done. So the global, it's not like top down where the global is defining everything that is done, but it's more kind of a lot of local processes are ways of working. That's very similar, and also kind of very kind of employee friendly and sustainable companies, like sustainability being high on the agenda. In terms of like data usage, maybe Unilever being kind of B2C, I think normally the consumer side is maybe a bit ahead, and there's a lot more data and a lot more stuff that you can do, and you see maybe the results faster and kind of optimizing. And for example, if you do like in the consumer side, if you did a campaign, you see the results straight away, and you have kind of like war rooms where you actually see what the company is doing. In the B2B side, it's maybe slower, and more of the sales is going to salespeople, and it's more of like I think maybe a bit more complicated processes in terms of like really seeing how do you utilize the data. You have to go through the more of the people and the processes. But I think we are maybe a little bit behind, but I think we are going in the same direction. A lot of like similar ways of working for global organization. How do you look across the business lines and function, and then also include the areas and the front lines as well?
Yes. I guess you and I, we don't really buy escalators, so or elevators that much. So
yeah, but it's surprising. Like I think that at the end of the day, the buyers are still people, humans, who also increasingly use digital tools, and in the kind of private life are used to utilizing digital tools. And I think that's something that we realized last year with the pandemic, that we were kind of forced to utilize more of the digital channels. And maybe previously we thought that all the sales has to go through people because like you have to have the physical salesman, but then we realized that actually more and more we could be utilizing digital tools and the data for also the sales forces, and I think it's accelerating the development needs a lot.
Yeah. Okay. Hey, then about the Analytics Center of Excellence. So this unit, what can you tell about that?
Yeah, so it's something that we are now building. So centralized COE unit that is then kind of made up of counterparts for each of the domains. So there's a lead that is then looking after the roadmap for the domain and making sure that the analytics agenda is kind of working to, of course, with the business partners to define the agenda, what are the business questions that we should be answering, and then turning those into analytics roadmap. And then kind of those domain-based tools, and then of course there's kind of double project management resource that helps to kind of take things forward. And then we have the competence team that is consisting of data scientists, data engineers, analysts, and also kind of BI people, then actually doing the work of being the kind of competencies that are dedicated to the domains to then deliver the roadmaps. And then, of course, underneath kind of there's the whole technology, so the data platform that we're building, all of the technologies that we need to be used. At the moment, they are not part of the COE, so we are kind of customers to the platforms who are looking after the technologies, but we are then creating things on top of the platform. So kind of being in a way between the business stakeholders and then the technology team, ensuring that the analytics roadmap is kind of taken forward and we define and develop the competencies further.
Exactly. So how would you describe kind of the background for this, the Center of Excellence, that there will be this one unit kind of,
Yeah. So maybe I guess you have a kind of on high level 3 options. So either it's like all decentralized where everybody does what basically what they want. So the teams are born in different parts of units, and that's quite often where companies start from. So you start kind of testing and kind of taking forward the data usage analytics and data science in different parts of the business. The other extreme is where you have the totally central team who's doing everything for everyone in the company. And I guess both of these extremes are kind of, I think we started from kind of having very decentralized, but then a lot of things are maybe we don't get the synergies and maybe the competence is not developing as it should be. And then the other extreme is it doesn't fit for us because you couldn't have a central team who's like far from the business and doesn't understand the business problems and questions and what are their priorities. So then we've kind of looked at these different options and thought that the COE model where you have a central team that can take forward the competence agenda and make sure that we work in aligned where we have common ways of working and we utilize the similar tools and the same platform, and so we need that. But then having kind of like a hub and spoke model where you then have very close connection and you are actually dedicated to the domain and delivering the agenda whilst then being part of the COE to have the common ways of working.
Yeah. Where do you see in general the biggest opportunities for KONE if you think about the analytics and use of data?
Yeah, so we've kind of created a model where this kind of maybe 4 areas. So one is the new business opportunities. So for example, the stuff that Olli and Juho will be talking about. So the predictive maintenance offerings and the kind of new services and new digital products and the people flow offerings that we have. And there's a lot of kind of new different kind of ideas of increasing the business. Then you of course have the kind of cost saving opportunities. So maybe direct ones are like, how do we make the data better available so that we can kind of people can work more efficiently, make better decisions and kind of utilize the data, and then also, of course, optimize things like the supply chain and our operations. Then you have the risk avoidance. So different things there. So like, for example, ensuring that we have the right data quality. So that we, when we make decisions, we make decisions based on the correct data, and we are not sharing data that is incorrect and that kind of stuff. And then you have the kind of asset utilization or capital utilization. So that we know we have the right levels of inventory and the supply chain is working efficiently, so that we don't have kind of piling up things when they are not moving anywhere. So kind of optimizing the utilization of the capital. And then you have got direct and indirect benefits from there. I think the biggest opportunities are definitely in the digital products side. There's also a lot of kind of process improvement side, and then kind of sales and marketing is also increasingly becoming a big area of kind of improving the sales and the targeting, and kind of where should we focus on our efforts, and what kind of product offering should we have based on kind of what is selling and what is not selling.
Yeah. So how do you see then on the other hand side, so the challenges that KONE has in this area? How would you describe them?
Yeah, so probably maybe like 3 different areas. So one is finding the best opportunities that are most feasible. So kind of balancing the big business benefit opportunities, but then those that are also doable. So sometimes like it's maybe easy to find big opportunities where we could be making huge benefits, but then the actual realization of benefits might be very difficult if the data is maybe buried in very old legacy systems. It's really difficult to get it out, and then you're actually struggling to deliver value. So like, how do you deliver value quickly so that you can kind of show the benefits and get people interested to wanting to do more? But then at the same time, when people get interested, the second part is like balancing the long-term benefits versus the quick delivery of benefits. So of course, in our size of the company, yes, you can do POCs, but then actual value comes from when you industrialize and actually change the processes and kind of deploy the things across the company. And that's where you need robust platforms and robust technologies. But then building the technology or infrastructure often takes a long time. So balancing that, actually getting benefits, but at the same time building the infrastructure. It's kind of like the metro here that I think like when it was built, it was like, oh God, I wish it was already ready. But now it's amazing that it's there. So it's like having the patience to wait for the infrastructure to be ready, but then at the same time trying to deliver some benefits that people kind of stay interested. And then I think data quality is a big thing. Especially we have a lot of legacy systems there, and loads of data that has been there for a long time, but maybe it hasn't really been thought of as an asset, so that it would have been kind of looked after as an asset. And now we are doing a lot of work on kind of putting together or putting in place the right roles to look after the data quality and ensuring that the processes are supporting the data quality, having the kind of data modeling and data architecture expertise to make sure that the kind of also the different systems are connected with the data, so the data is the kind of thing that goes through, and not just like having individual systems that don't really talk to each other. So maybe I think those are probably the main challenge areas that we have.
Okay, there is something in Q&A. So a question about like what has been the most exciting analytic use case realized or planned at KONE so far? How would you answer this question?
I think there's a lot of, so what Olli will be talking about, so it's a lot of exciting stuff in the predictive maintenance, so how we can utilize the data to really make the customers' lives easier when we kind of predictively see that things are going wrong, and then we can kind of avoid the customers having kind of downtime of the elevator or it breaking down when people are actually utilizing it. For example, if you're living in a house that has one elevator and you're living high up in the building, it's really annoying if the elevator is out of use. So ensuring that our customers have a really good experience and kind of utilizing data to predict that is really cool. There's also like really cool stuff in the people flow area where we can utilize the kind of data about people and optimize and kind of when we are planning the kind of building use, how should they be built in order to have the best possible people flow experience. Some really cool topics in the kind of pricing side and sales, kind of how do we ensure the loyalty of people and kind of churn analytics side. See kind of like how do we best serve people and ensure that they are happy, and then do things that make them renew the contracts. Probably those are the key ones.
Okay, there's still a couple of questions also in Q&A. Maybe answer this quick one. So in your experience, what percentage of companies' revenue is spent on data science analytics? You measured ROI on this investment. So
Yeah, probably depends a lot on the company. So of course, it's kind of maybe building up. So you have to start and showing the value and kind of make sure that you track the benefits and show the value. And I think it's a little bit tricky because like the value doesn't necessarily come straight away. And if you try to put some like hard business case KPIs, it might be that you're going in the right direction, but maybe the benefits are not coming as fast as you can. It's kind of like, of course, the balancing of like getting the benefits now versus building for the long term, and how do you balance that? I think there was some studies that the personnel in the analytics side should be like 10% of the business personnel, but that's probably like advanced. Yes. But then if you look at, say, Google, Amazon, maybe most people in those companies are probably somehow, maybe not data scientists, but like utilizing the data. So very different in different companies, depending on the kind of where they come from.
Exactly. And of course, in some cases, data analytics is becoming a hygiene factor. So it's very hard to measure this exact ROI now on using data, because it's just an intrinsic part of this all your operations. One question there are more questions now they're in questions and answer, and maybe I guess Maija, you can also type those answers afterwards, because we only have a couple of minutes, and since you currently have some roles available, so for the CEO, so we're in the process of recruiting, but maybe you want to tell a little bit about that, and because there might be interested people in the audience. So I'm going to share my screen while you speak. So,
yes. Yes, so as we were talking about, we are building the COE, and we have been recruiting people into the COE, and now we still have some of the roles open, and there's the QR codes for those roles. They are not in the Workday anymore, but you can send your application to the email address, so analyticsdatarecruitment@kone.com. So have a look at the job descriptions and send your application to the email by the end of this week. So we are kind of going through the profiles and the applications, but you can still send your application this week. So we'll go through that. And then on the other side, we are also looking for the trainees for next summer. So there are 3 roles. So one in my team, one in Olli's team, and one in the people flow team, in the team where Juho is. And there's the other QR code. So that is about 3 months over the summer, working in a interesting data science projects with our team.
What would you say as a closing argument, kind of like, there are now this 6 roles, some like data scientists, data engineers, you're hiring a couple, like more than one person there, but what type of people are you looking for?
Yes, so maybe one thing to think, like this is really high in the agenda of our leadership, and they really understand the value of utilizing data analytics, and this is kind of a big topic that we are now building the team, and we are kind of in the beginning, but there are big plans for this really changing the way that KONE operates. So huge opportunities for each of these roles to make the mark and do something kind of revolutionary for KONE. I think it's kind of like building the team is kind of like a startup. So maybe people who are interested in building something new, making a mark, and are not afraid of kind of getting stuck in and defining the ways of working and the team and building it up. So I think it's really exciting opportunity to do something really cool, really exciting team, and also make a mark in KONE, which is of course a huge company who has a huge footstep like globally as well.
Exactly. Yeah, I can only second that. I think these are great opportunities now for somebody to start new and the development-minded person to define this the ways of working of the new team. So please look them up, those job descriptions, and apply if you feel inclined.
Yeah, indeed.
Yes. Okay. So maybe now it's 29 minutes past the hour. Maija, any final remarks from your side? Otherwise, we then move to Olli.
Yeah, I hope this is interesting. Of course, it was kind of short introduction to this, and there will be more details from Olli and Juho have a look at the roles, and if you have any questions, you can either kind of put them into the Q&A or send them to the email there, and then we'll be happy to take it from there.
Okay, thank you very much. And remember, yeah, deadline is Sunday, this Sunday, because it's already actually past the initial period. So it's still the final, but this is a chance for the Helsinki Data Science Meetup participants to apply. Yeah. Okay, hey, thank you, Maija. And
thank you so much.
Now we continue with the agenda. So Olli, on to you. I guess you're going to share from your own laptop.
Yes, hello to everybody. I will share the screen. And make it a presentation. Yes. So, well, thanks for the invitation. It's a pleasure to tell about this, let's say, particular use case. As Maija described, if you look KONE as a whole, there are multiple different data analytics use cases that are realized or planned to be realized. And there was this maturity study, and this KONE 24/7 connected services, which I will explain shortly what it is probably among the most mature. So without further ado, I will explain a bit what it is. And I have to comment, there were excellent questions in the Q&A, and I will try to address those and probably keep the slide presentation shorter. So just to outline that, what is this KONE 24/7 connected services, and then I will explain that how we are developing it and what one needs to take into account to deploy data-driven automated solution in an industrial scale production environment, which is something that we have been doing. So before diving into details, just mention that there were a lot of questions about return of investment and whether it really makes business sense to do this analytics. And I would say that this is rather big investment from KONE's side, but it's a real product for our entire maintenance portfolio. And currently we have 1.2 million equipment in service, and we are able to deliver this IoT-based solution for every equipment in service. So also for non-KONE elevators and also for ancient elevators, for those we retrofit some interesting sensor solutions. But first, some description that what this actually is. So KONE has quite massive IoT generated by elevators, escalators, and building doors globally. It's not 1.2 million devices because the quantity and quality of data sent by different equipment depends on their type and age. And already in 90s in Europe, the alarm phones were regulated in such a way that they need to self-test every 24 hours. And at that time, somebody had a clever idea that let not just test the signal through the landline, but also send the fault code buffer that has been generated on the operating system. And actually from our own equipment, we have data generated since the 90s. So we have huge history and scale of data, which is obviously the backbone for the development of intelligent algorithms. And what we aim to do with all the analytics is that we help the technician, which is at the end of the day, it's the hands of the technician on site which is doing the actual work, regardless of what analytics we are doing. And because of that, we need to provide clear instructions Obviously, the data team is not inventing the instructions, but we have seasoned maintenance and installation experts that we collaborate with. And then we can use the data for scheduling the visits in different ways, and also provide information directly for customer. If they buy our service, then they kind of stay on the know that what is happening on the equipment fleet, which is obviously very convenient if you are running a shopping center or airport, for example. And since the technicians are the hands that will use the solution, quite a lot of effort is made for the ease of use and also for training of the technicians, because for many of them, this type of solutions are rather new. And they were scared that it is coming and take their job or something like this. But instead, after explaining things in a proper manner, they have adopted it very, very eagerly, since it's essentially helping their everyday work. And if I give some examples that what we are monitoring from the elevator, this is quite old slide because I don't want to go into details, but it is what you would expect that you get from the operating system of an elevator. So obviously from KONE elevators, we get all the fault codes and other notifications which are running on the operating system through a gateway which we have on site. And then for non-KONE elevators, we need to use more mechanical measurements made by sensors of various types. And in some cases, we also combine both. And same goes for the escalators. And we have quite big team which is dedicated for the elevator case. Currently, we have soon 23 people in my team, and then there is a slightly smaller team working on escalator side, and then even smaller team working on the building door side. And here is a slide which is kind of probably trivial for majority of the audience, but anyway, simple examples are good examples. And this is actually from real measurement, so it's not just a slide that we made up. And this is telling about a particular fault case where a curtain of light becomes dirty or otherwise stops working properly. So with what curtain of light does, it measures that when there is something between the elevator doors, they do not close, which you have observed when you have been using elevator. But when there is dirt on the curtain of light, then it might say, okay, there is something it been, but now there is no more, even though there was no movement. And how you can observe this is that the elevator reopening starts to increase. And if the curtain of light stops really working, then the doors just keep moving for a while, and after that elevator goes to a fault mode. So we can measure the amount of door opening over times. And I would assume that majority of the audience can guess that what kind of data analytics you can fit here, and with some domain knowledge come up with a very simple and efficient rule on here. And I would add that a lot of the things that we do is based on the domain knowledge. If we observe interesting phenomena, for example, acceleration of the elevator, it's very beneficial that we have in our disposal people who really know the equipment. So for example, we have an elevator which is constantly going down and then up, and it does this every half an hour. And then for us, it would be difficult to guess what it is, but then experts can easily tell that, okay, since it's a hydraulic elevator, there is a leak and it's doing the readjustment and so on. And that enables us to give very clear instructions for the technicians. So that's one class of the algorithms we are doing, which are kind of the expert rules. And obviously there's also the scalability that we get with the data and data-driven method. And I will later return to the topic that how we combine the expert knowledge with the machine learning stuff to make it really useful and benefit from both simultaneously. So the key areas for the analytics, what we do in the team is actually pretty much all, starting from the site. So we do quite a lot of edge computing where we use domain knowledge. We actually do some unsupervised learning also on site to calibrate our own algorithms automatically and things like this. And also a lot of feature engineering, because after discussing with the maintenance technician, we know that what kind of start kick and stop kick we should be interested. So we want to make the information as valuable as possible before we send it to cloud, and send only the valuable information to make the solution more scalable. And also it eases a lot the analytics happening on the cloud. And one of the things that we have learned a bit hard way is that you want to implement a lot of data quality confirmation procedures on the edge. So if you have, for example, two methods which are measuring approximately the same thing, and if it's not a computational issue, it's quite beneficial to run them both and then send the results to cloud. And then in the cloud, you can observe things depending whether the results are similar or not. So as I mentioned already, in the cloud, we of course do majority of the computing. So we have the simple rules. We do not measure the value of the rule by how complex it is or how advanced methods we are using. Instead, it is measured at how much additional customer value it brings, and thus how much additional value it generates for the solution and the value that we can sell. And we actually align, we work in 2-week sprints, every sprint with the business that what we are doing, and the business is very open towards us that what are the greetings from sales and what would be the burning issues to solve, and would it be possible somehow to observe this and that because these and those customers would be interested. And well, then we have the statistical models and artificial intelligence or automated decision making. I still hate the term artificial intelligence with the mathematics background. I would still say it's mostly interpolation of very high dimension with unknown function and then using that to do things. But obviously it is very efficient, and the AI is a much more fancier name. But essentially, if a cat can catch a mouse, nobody asks that what is the color of the cat. So we use whatever methods works. And also in such a way that the methods benefit from each other's, which I will return later. Then, obviously, as I mentioned, the most important part are the technicians on the field. And we are turning the data observations into sensible field actions. And at the same time, we have to analyze the back reporting data from field technicians. And if we compare the data coming from people making observations or machine-to-machine data generated by IoT, obviously the people make it much more complicated. Luckily in KONE, you saw in the second slide picture, it's a real Android application that the technicians are using. So when they are doing the back reporting, they are selecting of a given options that what was the component class that was broken, what was the condition of the elevator when you arrived, were the doors open or closed, and things like this. So we actually get globally unified data. So the fields are identical no matter where in KONE frontline the data is generated, which is rather valuable for us. And I would say for this type of industry, for 60,000 people company with about 30,000 of field technicians, it's rather good, and it gives excellent grounds for the data analytics. So there is no pen and paper anywhere. There is no field operating systems in different countries that would be different from each other from the data generation point of view. And in order to stay on track that what is really happening, we at least once a year, last year was exception, put on the blue overalls also in the data team, and then we spend the day with the technician and see that what he or she is doing, and try to observe and question and discuss as much as possible that how we could help. What data finding takes most time, what is found unpleasant to install, what feels complicated, and so on and so on. And as I emphasized already, in all of these cases, the domain knowledge is essential. There was question that what is more important, the platform or the domain knowledge? And I would say it is the domain knowledge. Every player on the market has access to the exactly same platforms, which are easy to take into use, and with same algorithmic libraries, and everybody has the same algorithm, and those will differentiate from the competitors which are able to use their domain knowledge in the most efficient way, and or have better domain knowledge than others. That's my take on that. Yeah. Then I talked a bit about what we do there, what kind of analytics we are doing under the hood. But in order to make this all in place, it takes quite a lot. And if one only concentrates on making the perfect IoT solution, and there are huge amount of excellent IT solutions in the world which are never taken into use for ridiculous reasons. And it's really important to try to avoid those ridiculous reasons. So in the beginning, here I emphasize the fact that it's important to get all informed. These are like the conditions that are required so that from my perspective, the automated data-driven operations is established and is working. So we need to have some scope. That's quite important. Then everybody needs to be informed. Otherwise, if they are informed too late, they might start to resist, even though they would not disagree with the scope, and then have the management support. And as Maija mentioned, in KONE's situation is excellent, that management really sees the value in this kind of work, and also justifiably so, since this 24/7 connected services, KONE has been selling it for 2 years already, with quite successfully all over the world, and we are having 6-digit numbers of customers already, and equipment out there. Then what is important is the collection of the data. And as Maija mentioned, this is related to the fact that it all depends on the data, and it's worth investing the time and money for the data collection procedures, making the data seen as valuable asset throughout the organization. For example, in our case, it is very important that we explain to technicians that when you take your time and carefully input into your mobile phone that what is happening on the elevator, it benefits you at the end of the day. And then we can explain use cases that how this happens. Otherwise, it might be that if technicians are not informed, there is something blinking again here, but I concentrate on the real work and just always press the first option. And then people doing the data analytics is against the impossible mission. And one sentence that I always like to say is that it's easy to argue that, okay, data quality issues, they are something IT related and not so relevant, and the data people are always complaining about it. But in reality, if you do not have the quality of the data or good quality data, then it's easy to question that do you even really know what is happening in the company? And when you ask that from the top executives, they usually open their eyes a bit more, that the data is the knowledge part. It is not just some rows in a file that we use to run use cases. Then this is surprisingly the easy part. If you have the data, then generating the model / AI is kind of easy if the objective is clear. And it's also the funniest part. One of the challenges is that everybody would want to be doing this, and then you have to make kind of workshops around it to share this entertaining part for people. And then when you put it on the operations, you really need to convince people to use. And what is the final challenge, or the challenge to think in the beginning, is the implementation to existing IT systems. So as Maija mentioned, we have quite a lot of different legacy systems and legacy data sources and things like this. But if there is the management support, it can be overcome the time and cost that will be needed when implementing to the existing IT systems. And it's a joint effort. And if some of the participants are not fully into it or do not believe it, then it easily just doesn't seem to happen. Luckily here we have the case where all of these conditions are met. Yeah. When thinking about this talk, I try to come up with various topics that would interest variety of audience, and now we are again jumping to a slightly different topic, but I think if you are running a data science team in industry, and regardless of a use case, I would think this is hopefully useful. So how to develop the algorithms that you put into production in fail fast and no waste method. So as I mentioned, we have the expert rules and we have statistical models, and then we have also the data-driven models based on the maintenance back reporting and remote monitoring archive, and also the constant data stream we have from the field. Then one wants to automate the validation for the candidates. There is often some business heuristics. So mathematically speaking, it's a multi-objective optimization task to make a best possible algorithm for, and of course it depends on the use case. And there is often some domain expertise, for example, that okay, this is algorithm is not that accurate, but it is quite safety critical, so we should deploy it regardless, or things like that. And this is then something that you want fully automatized. And these algorithm performance KPIs are something that then you are fine-tuning with the business constantly and being transparent about those. And then those which are good enough or are supporting, they are implemented. And then we work as a DevOps team, so we have invested a lot in strong CI/CD pipelines. Currently we are using GitLab, and then for the integration testing we are using Robot. So that when we deploy something to the operation, it goes through several environments, and there are no let's say there are rarely surprises when things go into production. And this is something that obviously data analysis and data science is art of its own, but when you implement it to the production type environment, one needs to adapt the same software development practices which are adopted elsewhere. And in KONE, we are relying on service R&D, in particular this DevOps and CI/CD pipelines. The goal is to make time from idea to production as fast as possible. And so far, this fail fast and no waste doesn't seem to fit here, except that we automatize the evaluation. But what is relevant is that every algorithm generates new data. So for example, in our case, we have algorithms which are triggering alarms when the elevator is having some specific fault mode. Then we notice that, okay, this algorithm is not accurate enough, or that it is not such a case that we can provide clear enough instructions for the technician. But anyway, we have that thing running on the test environment, and it is generating new data, which we can combine with the other data we have there. And in some sense, you can say that every algorithm we do is a feature engineering also. And then once this set of generated features starts to accumulate, then you can use data-driven models, some random forest or other. Random forest is this kind of universal first option, and quite often the good enough option then to validate that which features are important to predicting something specific, and then it can be basis for new algorithms. So even though something is not going to the production, it doesn't mean that it is wasted, because typically the effort which is made into designing the algorithm contains some kind of knowledge and some kind of ideas, and then this is generating new features. Yeah, that was more or less all I have here on slides. I can talk a lot about different random topics, but I'm curious what you have there in the questions and answers.
Okay, thank you, Olli. So this was extremely interesting, and indeed we do have questions there in the questions and answers. There are at least quite a few questions about edge. So what it actually means. In terms where is edge located, and do you apply unsupervised learning at edge?
Okay,
cloud,
that's
so forth. If you could open this whole topic up.
Yeah.
If you have any difficulties there as well.
Yeah, well, there are some of the difficulties of the edge is that it is on the edge, and in practice it means that it is on site. So depending on the elevator or escalator, we add some computational power, or in case of more modern KONE elevators, we are using the computational power of the elevator operating system to compute features and then send them to cloud. But especially in non-KONE elevators, where we are installing retrofitted sensor boxes on the elevator, this data quality confirmation on the edge is the crucial part. So if we just send, let's say, for example, start kick of the elevator, which I mentioned, we send it after every elevator movement. But in reality, to get that specific feature, it's a quite complicated procedure which uses a lot of domain heuristics, and elevators might be behaving differently. There might be some anomaly type use where people are jumping in the elevator or whatever. And then if we just send the measurement value alone, it might give misleading results. So if we, together with the measurement value, have some heuristics confirming that the measurement proceeded as we expect, then it is much easier for us in the cloud to classify that, okay, these measurements are more valid than these. And then, for example, when training new algorithms, we can use the more valid measurements as the training set. And then other difficulties in the edge is that obviously you need to physically go there and install the computing power in many of the cases. So it needs to be easy and fast to install. It needs to be rather cheap. So in order to scale in the business value, luckily this has become much more and more approachable since the price of the hardware has been going down. And then one challenge is the connectivity. In Finland and in Europe, typically through the mobile network, you have the connectivity quite strong. Then in some parts of the India, for example, it's slightly more challenging. And there one needs to develop specific solutions and additional battery solutions for the electricity breaks. Of course, such solutions are sold elsewhere also, but they are in much greater demand in those areas where electricity is not always guaranteed.
All right.
Great. Other questions?
There's one question about you also mentioned the training time. So how much training time do you need to train an AI model that predicts an error?
It depends how good is your pre-processing to the data and how strong are your features. We try to avoid what I would call a blind AI model, even though it sounds attractive that you take all the service order data, which is the maintenance back reporting. You collect there that when the elevators were broken, to put it simply, and then you collect the data before the event of breakdown, and then you just put all the data in and have a massive neural network running there, and then you come up with some kind of prediction algorithm. The challenge with this is that it's not so easy to provide very hands-on instructions for the technicians. And the quality of the technician instructions and the information that we are passing to the technician is really that is measuring the value of the system. We do have some blind algorithms. For example, when the technician is doing work, which is promoted by our algorithms, they can essentially give thumbs up or thumbs down. It's slightly more complicated, but we get technician feedback that when they are not satisfied to our algorithm, and then we can obviously predict that when the algorithm would not work and not send it at all. And that we can do kind of blindly and just use the accumulated data and variety of models to improve the quality through the scale.
How do you actually give this information back to those the people who repair those elevators?
They are using actually Android-based application. It's correctly named is KFM. As large corporation, we are full of abbreviations, and I think KFM is KONE Field Management, but don't shoot me if it's wrong. And through that system, they get the operational instructions of the front line, meaning that when you are stuck in the elevator and you call to the call center and I'm here, elevator is not moving, please do something. Then the red alarm comes to the mobile phone of the closest technician and they take the job and then they report back that, okay, I took out the person. And this is also used for the data collection for frontline operations, the invoicing, the spare parts and things like this. So it's through the application that the technicians are using.
Yeah, okay, very, very nice. There's some Somebody asks, automated evaluation and selection between models requires some well-defined performance criteria, but it's not
Yes.
always simple. And certainly MSC is not the best choice always. How do you do it?
That's here it is important to differentiate that the performance criteria of AI model, if you look at the academic papers, is very different than what we are using, because we tie it so closely to the use case that then when you communicate with the business, who always have some kind of what the dream model would be doing. And very often these goals are contradicting. For example, we could trigger algorithm every day and we would catch every failure, but nobody would be happy. Or we could trigger the algorithm only if we identify that the elevator is in flames or something, which is also super rare, luckily. And also nobody would be happy. So in reality, there is some coverage and accuracy or precision or recall, depending which terms you are using, trade-off, for example, in this case. And this is always requires some communication with the business that which of these options is better for you. But you are right, it's kind of the most important part, because it is the one which is guaranteeing that the algorithms are really solving the use case that they were designed for.
Yeah. Somebody is still asking about that Android app that you mentioned. So if you show the measured data, which triggered the maintenance visit to the maintenance people in the app?
Some of it we use. It is a matter of constant discussion with the technical help desk specialists and field technician that how much data they actually want to see on the mobile phone. And we have kind of two layers. One is the as little as possible, so it doesn't kind of disturb if not necessary. But then in front lines, there are always some specialist teams who are not located on site, but they can look to the data in much greater detail and then provide additional information for the technician. Not in every country, you cannot assume that the technician can very fluently read graphs or things like this. It depends what kind of regulation you have for the maintenance technician. In Finland, for example, maintenance technicians are very educated. You need to be electrical engineer, 6 months, I don't know how long, you need real work experience. Then you take 2 years of elevator school. Then you have half a year training, and every technician is able to do anything. And you go to elevators twice a year for one elevator. But in China, the regulation is that you need to visit every elevator between 2 weeks. So you can imagine there is a legion of field technicians who are very familiar with checking all that the condition of the elevator is fine. But at the same time, if you need to change the ropes of the elevator, which is quite complicated task, then it's a specific team which is able to do that. So in order to serve all of these different competence levels, we kind of have different levels of information that we are providing.
Highly interesting, yes. So one good question is also from somebody, is this IoT data, if it's collected or used for other purposes as well, just as it's business decisions, but how would you comment on that?
Well, it's a matter of constant brainstorming that the better use cases we invent, the more interesting it becomes. I mean, it was not that much driving the business, but last year I was doing some graphs that based on the elevator usage in hotels, in medical sector, and in residential, you could see the impact of COVID quarantine in different countries in Europe, and you could compare these with each others. And then in the autumn, you could measure that how much different countries were recovered and so on. So there is this a bit surprising uses of elevator data.
Yes. Yeah. Very interesting use case. Okay, hey, Olli, I think I would have one request for you, since there are quite few open questions and answers. So while Juho starts talking, maybe you can have a look and
yes,
reply to those questions.
I will try to type something there. So thanks again for the invite, and it was a pleasure to give a talk.
Many thanks to you, Olli. And now, Juho, I guess we will switch the presenter. The floor is yours.
All right, thank you. Do you hear me and do you see the slide?
Both. We hear you and see you, and the slide
Great.
as well.
So I will go. All right, so thanks for the opportunity to speak here, and also thanks for everyone for coming to listen to us. I'm Juho Kokkala, working as a senior specialist people flow analytics in KONE, and I'm talking about people flow. What do we mean by people flow might become clear during the presentation, or I hope it will become clear. But before that, let me first tell a bit of my own background, or how I ended up here and being interested in these topics. Before KONE, I was studying and working as a researcher in Aalto University, a master's degree majoring in systems and operations research, and then a doctoral thesis was about Bayesian filtering and smoothing algorithms. So basically like probabilistic state space models for dynamic systems. After defending a thesis, I got this PODOCO, that is postdocs in companies, postdoc grant for 6 months, which I spent doing research on elevator passenger traffic forecasting with Bayesian filtering. You may try to guess that which was the company that was collaborating with me during the PODOCO program. In September 2016, I joined KONE and have been at KONE ever since. But then to something more interesting than myself. So what do we mean by when we're talking about like people flow analytics or optimization? I will try to explain this by way of a story. So once upon a time, there was this office building where the users, or like the people using the building, started to complain about long waiting times in the morning. So you come to work and you give a call for an elevator, and then you wait and wait and wait, and you are late from your meeting, and that's obviously not a very good user experience. This case came to our table, and my colleague got some monitoring data and started doing some detective work to find out that what was the reason and what can be done about that. And it turned out to be about renovation and cleaning. So in this building, at that time there was ongoing renovation, and one of the elevators was all the time reserved for use of the renovation group. But still, like the capacity of the elevator group there was good enough that the elevator group was able to handle the traffic even with N-1 elevators. But then the cleaners, or the company responsible for cleaning the building, had started to perform the cleaning right during the morning peak traffic hours. And the cleaner took another elevator for their use, for the cleaning purposes. So then we were 2 elevators down, one for this renovation group and another for this cleaning group. And then the capacity was too low, and that caused the long waiting times in the morning. So basically we suggested that the cleaning will be rescheduled to some other hours than the morning peak. And this intervention was done, and people in the building lived happily ever after, except perhaps the cleaners who then had to work on strange hours, but at least the other users. And if I try to generalize from this story, then like Olli was in previous talk talking about this like maintenance things, or mostly like measuring sort of physical parameters from the elevator. Is the elevator working? Which is of course like necessary for getting good people flow. But then even if all the transportation equipment in the building are functioning correctly, it's still possible that there is something that causes a bad user experience or a terrible flow. So for example, here in the story, all the elevators in the building functioned perfectly, like going up and down as instructed, but then 2 of them just happened to be out of normal use, which was problematic for the normal users. So that's what we are sort of looking at, working on the, in some sense, higher abstraction level, assuming that the equipment mechanically, physically functions, then looking at like elevator group level or even building level. Okay, time for a commercial break. I know this was already advertised during Maija's presentation, but one of our summer trainee positions for data scientists is in this flow intelligence tribe, which is where we work on these things I am talking about. And I'm showing this here for 2 reasons. First of all, I'm of course like very keen on getting a good summer trainee to work with us during next summer. But then also I saw that this is a good text that I can steal for showing what the flow intelligence tribe, which is where we organizationally do these things, does. And next I will touch a couple of these topics mentioned here in a rather general level, and then I dive in a bit more detail in one analytics study. So first, simulation. We develop and use simulation and planning tools for planning like both new buildings and changes in existing buildings. So a classical question is that when you're planning a new building, how many elevators you need and what kind of, for example, speed and maybe escalators to handle the traffic that is expected in the building. So the building in the cleaner story during normal times handled the morning peak perfectly because someone had done this calculation before the building was constructed. Depending on the complexity of the building, it's like in some simple cases, there are these queuing theory type analytic calculations that can be used to determine the requirements. Then in more complex cases, we use simulation. And then as you see in the video, we have more recently started looking also into this more holistic view of the entire building, the also horizontal people flow, and enabling this KONE's people flow planning and consulting service, where we do both for new buildings and existing buildings, consulting of solving problems with people flow, which may be related to elevators, escalators, but may also be something else, like congestions in lobbies, and do we need to direct people to other routes or something like that? And someone asked in the Q&A about these COVID adjustments. So this in this people flow planning and consulting, we can now do also this health and well-being thing, where we can simulate the impact of this social distancing, or it's called physical distancing now, measures. So for example, if you introduce a limit of how many passengers can enter your elevators, but still the same number of people are coming to the lobby, then the passengers waiting in the lobby will probably violate the guidelines. And if you are opening your buildings, then you can use this kind of analysis to decide that how many, for example, workers can be invited into the office, so that the physical distancing guidelines can be still maintained all the time, even like during the morning peak, for example. And then another topic, intelligent elevator group control or optimization. So what is an elevator group? I talked about it or mentioned the term already a couple of times. Now I'm explaining it. So in large buildings, there are usually multiple elevators placed close to each other, and then also they serve the same calls given by passengers. So here are illustrated two different systems. One is this more traditional thing where you press like up or down, and then you wait for a while, hopefully a short while, and then you hear bling, your elevator comes, you walk there and then press a button, where do you want to go? Then on the right-hand side, there is this more modern destination control system where you already in the lobby give a call that where you want to go. That, for example, you are in floor 1 and you press the button, I want to go to 11. And then the system tells you that, okay, elevator B will serve you. Then you again wait for a short while for elevator B. Then elevator B comes and you walk in and it takes you to 11. But in both of these systems, the elevator group or elevator group control is responsible for deciding that which one of the elevators will come to serve your call and take you to your destination. And especially in a large building where many calls from many floors and multiple elevators is not always trivial. So the question of which elevator serves which call and in which order to travel. So this has been formulated as a mathematical optimization problem. Typically objectives are minimizing the waiting times of the passengers, or then the total journey times. Maybe other objectives such as energy consumption have also been considered. And then when there are many calls and many elevators, you quickly get this combinatorial explosion where number of alternatives is quite high, and then heuristic methods such as genetic algorithms need to be used. There's also a lot of published literature, both by us and others, about elevator group control optimization. I put this one reference here just to show that we had this magic word artificial intelligence that some people apparently hate already in 1997. But still we believe that there is, or we see that there is room for improving the intelligence here also even more to get even better service for our users. And that's why we are still working on this. And then people flow analytics or people flow analytics applications. By this we refer to this kind of data analysis for looking into maybe like people flow problems, for example, the investigation of the cleaner story or some other problems, and proposing interventions that might help. Someone asked about how to measure also in the Q&A. So some things in the elevator group level, we get like people flow things from the elevator group. Like of course the group knows when the calls have been given and how long the passengers have waited. Elevator car can also be used to count people coming in and going out based on, for example, load weighing device or this curtain of light device. But then for this planning and consulting cases, if we need to measure like outside of the elevator shaft, elevator lobby, and more holistically in the building, then we place some sensors to measure the people flows in the lobbies or corridors, for example. But okay, so these basically simulation, optimization, analytics are the three main data science related things we do in the people flow field. Or if not data science, then at least something like data science adjunct applying mathematics, computer science. And these of course also like relate to each other. When we develop new intelligent elevator group control algorithms, we can use the simulators to verify the performance improvements. Same for interventions that are found based on analytics. And then on the other hand, doing this data analytics increases our understanding of traffic in buildings and helps us know what to simulate in the planning simulations. So that was a general overview of what is going on in people flow. I'll now jump into a sort of case study about long-term forecasting. So in the optimization simulation area, we are quite major. This is something that was more new for us and like an exploration. So KONE has a long history on short-term forecasting, referring to forecasting for within a day, for example, for the next 15 minutes, which is used in the intelligent elevator group control. So it's useful to know what, not only the calls that have already been given, but also what will happen in the near future, like in this current situation, how many, or what is the intensity of calls expected from floor number 5, or what's the prevailing traffic situation? Is it a period of low traffic or like heavy up peak, like in the morning in offices? And that's also what I studied in the postdocs in companies project. But then we got interested in also this sort of more long-term forecasting. And the motivation here is that the usage of buildings changes, and it has been this trend that in recent years, for example, in office buildings, the number of people in buildings have increased in many buildings, and this then may cause problems with the people flow or need to adapt. So for example, in the cleaner story case, instead of taking one elevator out of use for renovation and one for cleaning, you would have run into the same problem by just bringing enough people, more people into your building. And we would like to, in the future, see this kind of things already before they cause trouble. So if there is an increasing trend of more and more traffic in the building, then we would like to see that, okay, if this trend continues, then you will get into trouble and start to think about possible fixes already before we get into problematic level. And also in the analytics cases, it would be useful to understand in a like time series analysis level the fluctuations in the building, because besides the possible issue or change that we are analyzing, there's all the time events that change the usage. So this first exploration we did was a master's thesis by Viljami Pirttimaa. Thanks to Viljami for these results that I'm presenting, but I have to say that I redid some plots, so if there is something strange here or something contradicting the written thesis, then it's my fault. In the thesis, we looked at, well, 7 different target variables on a daily aggregation gathered from a certain office buildings monitoring data. But here we will now look at a number of destination calls. So this is for each day, the total number of destination calls given in that building in that day. Destination calls means that type of thing where you already tell in the lobby that I want to go to floor 11. And the number of calls can be seen as a proxy for the also number of people in the building maybe. And here we clearly see what I previously already thought about, this trend of increasing number of people in the building. So in this building studied here, the amount of calls given in 2018 was pretty much double the amount of calls given in 2013, which corresponds to an increase in the number of people in the building. And then we can look at the weekly cycle. So this is like box plots of the distributions of the daily destination call counts grouped by day of week. You see this is office building, so almost nothing happens on Saturdays, Sundays. Sometimes some activity, but not a lot. And of the weekdays, Friday is slightly less active apparently than Monday to Thursday. And similarly, looking at the distributions of the daily destination call counts, yearly cycle, so grouped by week number and Saturdays and Sundays excluded here. You see a clear weekly cycle here, like the holiday seasons near where the year changes, and then also in the summer, and then this 1 week, somewhere near week 7 is this office building is in Finland, so this is this winter holiday or skiing holiday, and in the spring there are some outliers close to 0, which are I think related to Easter and this Ascension Day, whose timing varies from year to year. So this kind of data set has some missing data because for some reason data was not collected or was lost, and then a strong complex weekly and yearly seasonality, and then these special days such as public holidays, which clearly impact the traffic, especially in an office building, and that's what any model needs to take into account. So first thing done in the thesis was to look at imputation of missing data. Of course, some methods would natively handle missing observations, but some don't. So first thing William did was to somehow fill these missing observations. Here a reasonable thing to capture the yearly cycle and maybe the trend from year to year would be to first I'll take the count from a year back and the count from year forward and take the average of them, so linear interpolation between them. For example, this date is from somewhere during the summer. It's lower count than during spring and autumn. But then there is some calendar fun, which needed some heuristic rules. So in time series context, you talk about this lag operation, so 1 year behind. If you enroll leap years, then 365 days. But the problem here is that if you look at, for example, the this date or today from 2020, like 1 year ago, we're trying to get the 1 year back from then observation. Then the date 1 year behind is actually a Sunday. And you don't want to, in an office building, to compare Monday's traffic to a Sunday's traffic. And for these issues, in the thesis was defined this so-called smart lag heuristic, which is picking a reference value from a year behind, but in a sense, like instead of taking the 365 or 366 days back, then somehow cleverly selecting the reference value. So first of all, taking not the same date, but the same day of week and the same week number. Then if this reference date happens to be either a like known special day, so public holiday, or then missing data, then search a week back, week forward, and then 2 weeks back, 2 weeks forward. But I don't know if these cases occur in this data. Then furthermore, if the target data happens to be special day, then the smart lag is defined to be the same special day. So for example, New Year's Day is compared to the New Year's Day, or for example, for imputing New Year's Day, you take the previous and the next New Year's Day, ignoring the day of week. Similarly for this Eastern, that kind of like varying holidays. And then still there's the possibility that the reference value happens to be an outlier. So there was an additional rule for clipping those outliers. Equipped with this smart lag thing, and then I forgot to say, but for the imputation, then also another reference value a year forward was taken using a similarly defined so-called smart lead operation, which is like this smart lag, but looking at the next year. Then the attempted forecasting models here was this long short-term memory neural network type model, then this classical time series model, autoregressive moving average, but using this just defined smart lag thing. So like seasonal ARIMA, but instead of differencing with 1 year lag, the target for ARIMAs was taken by differencing with using the smart lag concept to take the reference value, then XGBoost, and finally as a reference, just using the heuristic smart lag reference value. So if I want to predict today's traffic, I can just take the corresponding reference date from the previous year and use that as the prediction. And the process was such that the data up to end of 2018 was during model development, so feature selection and parameter tuning used as training, and then this 2019 as validation. So the models were optimized based on their performance on the 2019 data. The thesis was started during beginning of 2020, and we had the quite reasonable idea that let's collect data that occurs during the time the thesis is being done to get a final out of sample test set. But then something happened, and somehow suddenly in mid-March the traffic in the building changed completely, and nothing like this had never been seen in the training data. So for the thesis purposes, we reasoned that it's hopeless to assume that the forecasting model would capture this. So in the evaluation part of the thesis, William did just this. So as the final out of sample test, look at only the first 2.5 months in 2020 before this abrupt regime change happened. Quickly about the results. Our left-hand side here is just the validation set during model fitting or model development, so maybe not that interesting. So right-hand side is the actual out of sample test. So forecast for 2.5 months ahead and evaluate the root mean square error for the predicted daily counts for that 2.5 months. And here it happened for this destination call data set that actually the heuristic of just using the smart lag reference value outperformed the machine learning statistics-based methods for all 7 target variables. This is looking like taking each of them as a univariate time series of daily observations and performing the same forecasting exercise for them, and then taking the normalized root mean square error, averaging them over the different target variables without performing any fancy statistics. Basically, you see from here that they all have the same performance. There are no clear differences. To conclude, what was learned during the data analysis exploration or the master's thesis? This kind of traffic data, especially from office buildings, has strong, complex weekly and yearly seasonality that needs to be taken into account, and these public holidays cause some headache about the forecasting models themselves, or their performance didn't learn much with this testing data. So this one test set from one building is not really that much, or it's more like actually sort of one data point, because in this building happened that the increasing trend had somehow stopped for 2019, but then in 2020 it again continued the increasing, and none of the forecasters captured this. And this is sort of like your prediction errors for different days are correlated, because if you under predict the first day, then that probably means that you have under predicted a trend in the traffic of the building, and you will under predict the other days too. So this was a great master's thesis, good learning exercise for us about this. models and how to analyze this kind of data, but then in future research should look at like data over multiple buildings and over different years. And then of course, none of the models also saw this COVID-19 pandemic. And then I'll just mention that besides this forecasting study I showed here, then in this thesis also this kind of anomaly detection of trying to find exceptional days that are not in the public holiday calendar. So for example, was spotted like bus strikes causing lower traffic, or then some events in the building maybe causing higher traffic. And I will conclude here, and if there are any questions, then might try to answer them now. Thank you.
All right. Hey, thank you, Juho. So we still have some time for questions. So, for example, you partially answered this already, but maybe you can open like, do you monitor this people flow continuously in up and running systems, or is it done case by case? How would you answer that one?
For like this,
yes,
we can get from our own elevator group. So this, like what happens in the elevator shaft and in the lobby. So this amounts of calls and passenger counts and waiting times to destination, that is basically continuously monitored by the elevator group. But then when you look at the like more holistic building level, so move out of the elevator shaft and lobby into the building lobbies, then I think we don't have continuous measurements. But for this, for example, for this planning and consulting cases, if we need this kind of measures, then we place some sensors for some time in the building to get those parts of the people flow that are not related to our own equipment.
Yeah. Can you tell some examples about some interesting cases, maybe where you have monitored, like what type of buildings are the most interesting for monitoring those people flows? If you think of office buildings, shopping malls, whatever, airports, are there differences?
There are differences, yes, and I don't know if I have any interesting or good case in mind now, but in general, I think these like multi-use buildings are maybe most interesting, or
okay,
also like this people flow planning. I think traditionally, there are planning guidelines for like office buildings, residential buildings, hotels, but then nowadays there are like more and more these kind of, for example, buildings where you have both office and maybe a hotel, or then complicated things like airports and metro stations, and that kind of would be maybe the most interesting.
And so what about this? Count sensors, camera recognition. So to what extent do you use also other type of data to monitor, and what type of devices to monitor people's movements?
Okay, so like for these continuous operations, we really do not have like any additional sensors, except that we have basically like the elevators, escalators themselves act as sensors.
Yeah.
Then for this like continuing or not continuous, but like case by case monitoring traffic, then we use this some kind of like maybe not cameras, but similar like off the shelf like people movement tracking sensors and people counters.
Okay.
I don't have the details.
Yeah. Is it so that they, as you said, that they are there for a certain period of time? So
yeah, they are there for, at least our current type of operation is that we don't continuously have typically this kind of, to my knowledge at least, like this kind of sensors, but they are placed for when we are doing a planning case, or then this like build consulting service, then they are placed there for like a day or a week, or what is needed to get good measurements for the case-by-case analysis.
Exactly. Do those elevators, do they, like somebody is asking, do they learn on the fly and adjust the floor presence, or according to people, or is it something that's done, then you monitor the elevator's behavior and then adjust?
They do learn, yes, like based on gathering basically either based on calls or measuring the people entering, exiting, that this is used for this, as I mentioned, this short-term traffic forecasting, which can then be used for optimizing the call allocation, but then also like optimizing the placement before a call is even given. So yes, we do have this kind of learning.
Okay. And a question here. So if the people flow can predict if an elevator, an escalator has been located in the right place within a building, and if so, can this information be fed back into building design? So more if the data can also but then be used more in this the design phase of this whole building.
Definitely yes. I think currently like mostly manually or this like human intelligence approach that, for example, like when planning a new building, we try to get as soon as possible into the discussion so that like even before the constructor is buying the elevators and escalators, then try to influence during the building design phase to influence like both the elevatoring and also maybe more holistically this people flow planning.
Yeah. Olli, by the way, if you want to jump in, so feel free to also, because I think you may also have some answers to these questions.
Sorry, I didn't catch it. I was too busy chatting in the Q&A. So what was the question?
It's more, for example, about the data, if it's then fed that's captured from elevators back to like a building design or other use cases. Maybe also maintaining buildings and so forth. So if there are these kind of loops.
I know that for the airports, they want to have a bit more raw data and incorporate it into their own monitoring systems, which they have in their central monitoring room. Because obviously for them, if the escalator in some gate is not working and they need to, as fast as possible, redirect the plane to a different gate and change the onboarding on things like this, they do not want to get into separate KONE system to do it. I didn't talk about it, but these APIs to the data that the elevators are generating is one of the things that we are also providing for customers. It's not what my team is involved, but it is seen as a great customer value for many customers. So that is opening many interesting things, and we know that we have customers where we have robots using the elevators. So the robots have direct access to the API of the elevator and can call the elevator for themselves and things like this. So that is enabling interesting possibilities. And then, I will stop there, but that's a good example.
Yeah, I think there's increasingly cases on kind of smart building ecosystems, and even some sales cases have a prerequisite that we share the data about the building. It's like big developers want to feed the data into their systems, for example, energy consumption tracking and that kind of stuff. So I think it's increasingly, maybe it's not major thing yet, but we can see that it's growing area, kind of data sharing thing from the equipment.
Yes. Okay. Maybe there's also Olli, some questions that you said that you have been busy answering them that would be interesting to share with everybody. For example, Petri is asking about this MLOps side. So how you do that? I guess this might interest also more people.
Well, it interests many, and MLOps. I will put the video also, so you can see my head talking here as well. So the MLOps can mean many things, and let's say in the in the dream or nightmare case, depending what you end up with, you have an autonomously learning model in the cloud, which is deploying itself directly to the production through some automated testing procedure. And that, to be honest, we haven't implemented yet, since we see there is still a bit of risk that how you make sure that when the model is better than the previous one. In earlier answer, I mentioned these different heuristics by which together with the business, you evaluate that whether the model is good. And it often incorporates a lot of domain knowledge about the safety criticality of the issues that we are dealing with, or what is the customer expectation, or if we alarm customer about 2 unnecessary things, then we've got feedback from this country that this is annoying, and so on and so on. And all this is quite difficult to automate. So what we do in practice is that when we do the models, we do the automated testing, but we do not automatically deploy to production new models. And after that, then the model evaluation procedure is identical regardless whether it is machine learning model or expert rule or more traditional statistical model. So it's a good question. And to be honest, I would be also very curious if someone has implemented this successfully in such a way that is generating business value. In particular, in comparison with this so-called reduce ML ops, where you kind of have fixed ML model running on the cloud, and then you mostly manually improve the model, and then you deploy the better model on the cloud, which is, I think, what majority of people are doing. So unfortunately, I do not have here more advanced solution to present.
Okay, sounds like a good start for a good discussion, actually. So I guess people can also email you, Olli, directly. There's one question maybe to both of you about privacy. I guess people are always getting concerned about data transfers, people movement, and so forth. So how would you comment that? Does KONE spy on people?
No, I mean, that is what the legal team is very carefully looking after, that the solution that we are selling is according to the regulations of the local market. After saying that, the regulations in Europe and Asia are quite different. And for example, in China, the customers are expecting solutions that you couldn't sell in Europe.
Okay.
But I mean, you can do the facial recognition, and you know where people are going. You can optimize the people flow also based on that.
Yeah.
And open I mean, KONE is doing elevators, escalators, and building doors. And I forgot to mention also these passage gates, which you have in, for example, when entering the metro. So this physical gate device you can connect with the facial recognition system, for example, which I know they are selling in Singapore, for example. But it is something that the legal is always very careful about. And in general, in Asia, the attitude is very much different, that it's more technology, but the better. And in Europe and in US also, it's more about this individual privacy of people.
Yeah, I guess, you don't need to know, at least in Europe, who it is. It's more like you're counting people and when they go.
And actually, because of that, if we have some camera solutions on the edge, we do not transfer those images, also for practical IT reasons, but also for privacy reasons. We compute on site the number of people and then send only that data. And it's something that we are very carefully looking after.
Yes. Okay. Hey, at this point, I think we are very good on time. So thank you very much now, Juho and Olli, again, for your interesting insights. So maybe as very shortly, I'm still gonna share my screen. About next steps. So basically, this one. So if you want to host a Helsinki Data Science Meetup, so you're most welcome. And even though it's called Helsinki Data Science Meetup, now considering that we're all virtual anyway, and even now today we have people from not only Finland. Yeah, feel free to join. As you saw, it's you get quite good audience. We were some 240 people at the most today. So if you have interesting cases and would like to share within a community of like-minded data people, so contact Tizian, who is in charge of Tizian, in charge of organizing these events. And there's also a QR code again, so to where you can follow us on LinkedIn if you want to be the first ones to know about the upcoming meetups. So we'll most likely have the next week meetup in a couple of months' time. There will be more information to come. I said, follow us. And as a very last step, now would like to first thank KONE for hosting today, and remember to apply for those jobs if there's interest there. But we also, when you now sign out, there will be a short questionnaire that we would love to have you answer and give some feedback. Maija, any last words from your side?
Thank you, first of all, for having us host it. It's been great, and thank you for everybody who joined. There's been a lot of people on the line and very excellent questions, and something that also made us think about the answers, and really good to kind of share the thinking and get us think as well. Please have a look at the roles if there's something interesting, and we will be joining the next ones as well to hear from the other companies.
Exactly. Okay. Hey, then remember to answer the poll coming up. Thank you to presenters, to participants, to everybody from this time. Bye-bye.
Thank you. Bye.